Alright, we're looking at the homework on page 556 there, and we're looking at 1 through 3. Question number 1. A balloon is rubbed against the denim, probably blue jeans, and it gains charge of -8 microcoulombs. Micro, first little lesson here. Microcoulombs means times 10 to the -6th coulombs. Sorry, I forgot the unit there. So times 10 to the -6th coulombs. Anytime you see micro, that's what that means. And if you look at the homework, you see it here, there, and there. So you're going to see it quite frequently in this chapter. So you got 8 microcoulombs. What's the force between the balloon and the denim jeans when the two are separated by 5 centimeters? Now, what you got to think about here, if the balloon gains a charge of -8 microcoulombs, you have to think to yourself, where did that charge come from? Go ahead, think about it for a second. Pause recording if you must. It came from the jeans themselves. So if the balloon's -8 microcoulombs and it stole that many electrons, then the jeans therefore must have lost those same amount of electrons. So the balloon's charge is -8 microcoulombs. The jeans have an 8 microcoulomb charge. And we want to find the force between the two. So to do our math here, let me kind of relocate the equation a little bit down towards the bottom of the recording. Scoot that. Alright, here we go. Coulomb's constant, Kc, times, come here, having a hard time grabbing stuff here, times -8 microcoulombs times 8 microcoulombs, all divided by 5 centimeters, and you go through and you calculate that out. Go ahead and pause recording if you must in order to work that out. Go ahead, hit pause. On to number 2. Here you got 2 conducting spheres placed 3 centimeters or 30 centimeters apart with a charge and a charge. Find the force. Well, then our first part of this is simply manipulating Coulomb's law. Charge 1 times charge 2 times Coulomb's constant. Got that tossed in there. Divided by the distance squared, and you'll solve that out. The second part is asking, part B. The spheres are connected by a conducting wire. After equilibrium has occurred, find the force between the spheres. Well, if we're going to find the force between these two spheres, we must know the charges of the two spheres. So let's look at my equilibrium bucket here. If I have 18 here and 12 there, and we ground them out, grounding in this case is not going to make everything be neutral, equilibrium down to 0. It's going to be equilibrium down to whatever's left over. So what we do is if we take our 12 here, let's drop 6. Oh, ungroup them. Drop our 6 of the blue ones in, and we drop in. Oh, that's not right. Ungroup. Drop 6 of the red ones in, and then drop 6 blue in, and 6 more red ones in. That leaves us with a net. If you're trying to make an equilibrium between 18 and 12, that leaves us with a net of 6 laying behind. If we were to distribute them evenly, 1, 2, 3 times 10 to the 9th, -3 times 10 to the -9th, and -3 times 10 to the -9th would be what we have in equilibrium. So our goal is then to take our -3 times 10 to the 9th and our -3 times 10 to the 9th, now that they're grounded out and equaled out with the distance, and find the force again. So we're still manipulating this equation. Part A, using the original given charges in the distance. Part B, then after we find equilibrium with all these other charges, kind of got balanced out, and you do your -3 and your -3 times e to the 9th, and you solve for number 2. So go ahead and work through those. Hit pause until you're ready to move on. Now for number 3, problem is set up a little bit differently here. We've got a charge of 60 microcoulombs and a charge of 50 microcoulombs and a force of 175 newtons. Find the distance between the two charges. So you'll plug in 175 right here, coulombs constant of course, the 60 microcoulombs and the 50 microcoulombs, and you'll be solving for distance. Now to solve for distance, remember you're going to have to multiply your distance squared over. You're going to have to divide by the force, and when it's all said and done, you're going to take a big old square root of everything you have hanging out over here, and that should give you the distance between them. So a few things to remember out of this homework assignment here. Let's see, come over here. 8 microcoulombs equals 8 times 10 to the negative 6th power. Big idea we took from there. And our Coulomb's law here, where the force is equal to Coulomb's constant times charge over distance squared. Good luck.